So a little bit about me. My name's Adam Chester. I go by the alias XPN sometimes, depending on what I'm publishing. I work for Spectre Ops. I've been here now for a year today. So today's my 1 year anniversary at Spectre Ops. I'm a service architect, which means that my primary role is to be dropped into engagements kind of as and when needed, provide ad hoc support. Um, and generally just be positioned in the business to make business improvement decisions, like technical business improvement decisions. Okay, so let's kick off with how everything started. So, as I say, my primary role is to be dropped into engagements and allow consultants to kind of request ad hoc support as they need. It was a brand new role for me, so I started in April 2024. And I think this request came through in April 2024 as well. So starting off quite strong. Um, as I say, the primary goal is exactly what I've explained. It's kind of to be dropped into these engagements and provide this support. So there was a request that came through from a red team operator. And basically what they had was a database backup. And within the database backup, they believed it was for a product called ADSelfService created by ManageEngine. And the person who brought me the person who made the request basically said they've interacted with this product in the past. They believe it's got some value in terms of the data that's actually presented. Is there any way that we can take this database back up and actually start to recover some information from there? So essentially the request was simple. Can you recover the encrypted data from this database backup? So first of all, did a little bit of research. What's ManageEngine? Kind of what's this product about? So ManageEngine is a Zoho company. So Zoho, you may have come across it in the past. I think they offer normally like webmail. They're a webmail provider. A couple of other products, but ManageEngine is another company essentially that falls under them. They provide a suite of tools to manage Active Directory. So the one that we were particularly interested in was the ADSelfService Plus tool. You may have also seen the AD Manager Plus tool as well. So we won't be covering that in this talk. But as you kind of see some of the things that we unveil, probably other products, you might want to take a look at those as well. These databases, the database backing these products will typically contain like domain admin credentials, just as a function of what they actually do. Obviously, they're used for managing Active Directory. So quite typically, they'll have to have privileged credentials within there. They can use different backend databases. So typically when you deploy these products, they'll come with Postgres database bundled. Quite often what you'll see is that people will migrate that across into using Microsoft SQL Server, just ease of management within Active Directory environments. And that was basically the case here. We saw Microsoft SQL Server was the primary database server that was being used. So as I say, we've got a back file, which is Microsoft SQL database backup. It's encrypted, and recovery was kind of a long shot. So obviously, I'm brand new into the job, just changed from another company. You kind of want to impress a little bit. So I'm sure many of you can kind of sympathize with that. You want to kind of make your stamp in the company, show that they've not made a terrible mistake by hiring you. So I basically started to look through this and I thought, well, kind of all the requests to get, I've been thrown a little bit of a lemon here because like there's a good chance that this is not going to work. I'm not going to be able to kind of give any useful result from this. So some of the thoughts that we're having at the time was, Microsoft SQL Server crypto, like I had no experience with this. It's probably related to DPAPI or the DPAPI master key, which typically sits, on a SQL server. So actually just by having this backup, which is encrypted, it's probably not going to be all that useful. The other idea as well, the key material may be actually on the SQL Server itself. So again, without having access to the SQL Server where this database backup was taken, probably not all that useful. And also, basically, I don't think I'm going to be able to kind of recover anything from here without access to the SQL Server itself. But what I wanted to do was to at least prove that was the case. So, if I wasn't able to kind of materialize some kind of data from this backup, I at least wanted to show like why that was the case. So basically I was being a negative Nancy. Apparently this isn't a way that researchers normally kind of approach issues. Apparently they're a lot more positive than I am. So I've had to do a little bit of work since joining Spectre Ops to kind of stop talking myself out of situations as to why certain things won't work. I still do it, but I don't do it quite as much. But yeah, pretty much a negative approach to kind of it. But I wanted to prove to myself and prove to the person who asked exactly probably why this wouldn't result in any kind of useful material. So to be able to do that, we have to dig into SQL Server encryption. As I say, it's not the most exciting topic in the world, but we'll try and keep it light. There is a little bit of low-level stuff in there as well for anybody that likes reverse engineering. So in terms of SQL Server encryption, it's used primarily to protect data within the database. And the reason that it exists is as a database admin and as an application developer, you don't want to be dealing with the underlying crypto or encrypting data before it goes into a database and then it's encrypted at rest. So what Microsoft have created is this transparent layer that kind of sits between the developer and SQL. So once the developer kind of interacts with the database, they interact with it in a normal kind of way. They'll insert data into there, and then when the database is sealed or when the encryption key is closed, then the data is encrypted at rest. So primarily what we're seeing here is exactly that in play. You've got a backup file which is at rest, so it's encrypted, but actually when the interaction's happening from a developer perspective, they never have to really deal with the encryption all that much. This is called transparent data encryption. So that's the name that Microsoft give to this particular technology. So what does it look like? So it looks basically like this. So at the top, we can see we've got a database which uses TDE. The data or the master key hasn't been unsealed. So we have hex data essentially, which represents the username and password, which have got encrypted values within there. And then once we unseal the database and unseal the crypto keys, then what we see is just plain text. So, at rest, this is all encrypted, but actually we're seeing this as clear text, which is exactly what an application developer would see as well. So I kind of like this visualization which Microsoft created. So it's like this wheel of doom thing in terms of like how the crypto works in the SQL world. So everything starts with a service master key. So you have a service master key that's created using DPAPI. So hint, it's kind of what I suspected initially, and it's not looking too good. The service master key is created during install. So you install SQL Server, you end up with a service master key that's created. You also end up with a database master key as well. So the database master key is encrypted by the service master key. You have a certificate or an asynchronous key that's encrypted by the database master key. You have a symmetric key, which is encrypted by the certificate or asymmetric key. And you have a symmetric key that's been then used to encrypt the underlying data within the database. So to put that in another diagram, which is much more unprofessional because it was created in Excalibur, which is awesome for reports if you guys have never used it, if you drop these diagrams in there. If we compromise any layer kind of this SQL circle or SQL kind of crypto stack, everything below it falls. So you've got the typical, anyone that's ever done any like PCI testing, the concepts of data encryption keys, key encryption keys kind of apply here as well. So you've essentially got a chain of key encryption keys leading to the data encryption key at the bottom, and then that encrypts the actual data. So if you, for example, manage to compromise the service master key, then that can be used to reveal the information in the database master key and so forth. So to keep in mind, if we can crack any one of these layers, essentially everything below that kind of falls. In order to start using SQL Server encryption, we need to create the database master key. So bit of T-SQL there. This is encrypted using the service master key. So again, the DPAPI master key is used to be able to encrypt this. You can use a select from the symmetric keys table, and that will kind of show you information about the database master key row. So it looks like this, kind of uninteresting. So you can't actually see the generated key value when you perform this select. You'll just see reference to the database master key and a bunch of other kind of fields as well, including the algorithm description field. Instead, there's another table. So there's a key encryptions table. And within that, there's a crypt property field. And within the crypt property field, you have a blob of data. And that's essentially the encrypted key itself that kind of sits there that we want access to. There are some interesting fields within that table. So there's a crypt type and a crypt type description field in the key encryptions table, which look particularly interesting. Microsoft do provide a table of kind of these descriptions. So we can see here we've got an ESP2 encrypt type. And we can see there that Microsoft have helpfully said that that's encrypted by password. And we've got ESKM, which I don't know what Microsoft say about that, encrypted using the master key. So really high level stuff. Microsoft kind of point out what these fields are, but don't really provide any kind of like lower level details, which, I mean, as a security researcher, you kind of want to understand a little bit as to how the actual crypto itself is working. So basically what we need to do is to go low level. So this is where we fire up the debugger, reverse engineer some of this stuff and try and figure out what's going on. And again, all this is through the desperation of, as I say, like a new job. So I'm probably going a little bit further than what you would normally do with something like this, but we kind of want to get to that answer to understand, you know, why we can't kind of achieve what we've been asked to. So in terms of setting up a lab environment, what I did was set up 2 SQL servers. So we had SQL Server 2008 and SQL Server 2019. API Monitor, which is an awesome tool for kind of understanding what APIs potentially are being called to shortcut that process. We set that up as well to use that. And then there was X64 debug. For anybody that's ever tried to install like WinDebug on like a server platform or an older kind of Windows Server platform, it can be a little bit of a pain, especially in my lab as well, where they didn't have direct internet access. So sometimes X64 debug will get you where you need to be. If not, you'll have to go through the pain of installing WinDebug, which is a very useful tool, but it's not the easiest to install sometimes when you've got an offline system. So API Monitor was used, and basically what we were seeing was that when I went through and created a new encryption key, we could see that the bcrypt hash data APIs were being used. We can see obviously the data being spat out as well in terms of the password that was being used. And more importantly for us, it gave us an indication as to where we actually needed to start reverse engineering. So there was a SQLlang.dll within Microsoft SQL Server. And we can see that from the call stack was actually responsible for invoking the bcrypt APIs. So gives us an immediate indication that's kind of where we need to focus when we're doing this reverse engineering. And the symbols available for this as well. So that's part of the battle sometimes, just kind of getting that helping hand from Microsoft to make the, you know, the underlying functions within the DLL, you know, somewhat verbose and kind of giving us that information. So thankfully that information was available to us. So the plan basically became this. It became, what we're going to do is we're going to go through all the crypt APIs, or a kind of the common crypt and bcrypt APIs. We're going to go through and add in breakpoints, and we're going to see kind of what triggers when we create a new database master key. Hopefully one of these APIs will trigger, and then we'll review the encrypted data, and then we'll rinse and repeat, right? So we'll kind of understand eventually what's leading to these APIs being called, kind of, you know, relate this back to the DP API master key, and kind of show that this is the stack that's actually being used to actually encrypt this data. So unfortunately, we do hit a breakpoint on crypt unprotect data. So again, this is all in the DP API world, which has a tie to the SQL Server itself, which is primarily what we didn't want to see. But again, kind of useful to at least know. So the stack trace is a little bit small here, so you can't see it, but there's 2 particular interesting functions. There's the DB master key decrypt call, and there's the service master key initialize call. This basically points to the evidence that we had up front, which was that the service master key is being used to protect this database master key. So everything's kind of looking kind of as we suspected when I was being a little bit negative as to how all this kind of relates to each other. And Microsoft are doing exactly what they should be doing, right? They've got a database server which kind of ties all this data in, and you need access to the SQL Server to be able to gain access to the service master key. So again, let's prove it out. So we've got this crypt unprotect data function. That basically the data being passed through to that matches what we saw in the key encryptions table. So we've got a match now. We've got the DP API call that needs to be made, and then we've got the underlying data, and we can see here that we're in the right area. There's also like optional entropy as well. So again, some people will use this as an increased form of randomness when you're using DP API decryptions. Some people will hard code this. But within the registry key, you'll find this security key, and then there's an entropy field within there. And within the entropy field, we'll have this data blob, and that's passed along with the crypt unprotect data call, and it's that is being used to decrypt the database key itself. So the The code looks like this, and that we'll kind of need to use to be able to decrypt that. So again, kind of useful if you manage to pop a SQL Server. This will kind of get you there, so you can start to decrypt that data without having kind of any underlying access to the crypto key. You'll just kind of need to execute this on the SQL Server itself. So unfortunately, this doesn't help at all because we've been given a database backup and we don't have access to the SQL Server. And we know we need clear text database master key, which we don't have. So getting ready to go back to my colleague and say, unfortunately, you've made a terrible mistake by hiring me. I can't help you. So we'll kind of cross this out and we'll say we can't do anything with the service master key. Is there anything else that we can do? But we also seen earlier on that when we created the master key itself, we had to kind of include a password. So like, what's the password used for? We already know that there's this relationship between the service master key and the database master key, and yet we're kind of giving it this password when we create it. And you can't create a master key without providing a password. So some more questions that I started to ask myself at this point as well, which was, how is the password actually being used and tied into the service master key? Is the password actually ever stored in the database itself? Is all the key material that we need actually stored within the database backup, right? So is this password or something related to the password stored within the database backup? And can we somehow brute force this key if that's the case? So obviously going through and trying to figure out the answer to that question, we add another breakpoint to the bcrypt hash data function, which was the function that we saw earlier on within API monitor, which we need to hook. And when we go through and we create, a new password, we see a breakpoint that's hit as well. And we can see the parameter being passed is actually the database password for the database master key that we're kind of providing. So we can see here we've got like ABCDE, which was the secure password that I was providing at the time, and we can see here the breakpoint as well. So a shout out to anybody that's ever done any kind of like Microsoft research, reverse engineering, anyone that's ever taken a look through some of the SCCM stuff that my colleagues have been kind of producing. Whenever you see certain function names in the Microsoft world, you know to pay attention. And one of them is anything to do with obfuscation, anything to do with obfus, or anything that's not crypto, basically. Like they use their words, quite carefully. So when you see obfuscation, I think that's how you say it, you want to pay attention, you want to kind of dig down here, and that's primarily what we're seeing within the stack trace as well, is this obfuscation key search encryption by user data. So made a good place to be able to dig into a little bit more. So we start to disassemble the search encryption by user data function, and something pops out, which is a thumbprint. So again, it's something that we've not really seen so far. So we add in, a few more breakpoints and kind of see what's going on. And what we find is that there's a hex encoded value that's being passed into this function. We can actually find reference to this hex encoded data within this further table, which is the sysobjects key crypts table. You do need a DAC connection to be able to access this table. So it's a dedicated admin connection. Some of you may have heard of it before, but it's essentially a debug mode or a debug connection that you can make to SQL Server. There's certain restrictions on there. So I think only a sysadmin can connect to it. I think there's only one connection that can be made at any time. But the data itself can be found within this table. So you can see here that there's a match between the two fields. There's the hex representation at the top, and then the thumbprint value, which is actually kind of within that table itself. What's quite interesting is that this table looks more or less identical to the key encryptions table, but now suddenly this thumbprint value is kind of surfaced. So again, another place to kind of dig into a little bit. So in terms of what we was kind of seeing, so if we analyze the compare partial thumbprint function call chain, what we see is that we have a decryption password that is hashed. The password hash is actually salted, and then the hash password and the hashed and salted password is compared against the database thumbprint. So this is ideal for us, right? So we've got potentially a way to be able to kind of access some kind of like persisted hashed value of this password that we've kind of seen. So why does this exist? I think it exists because of this reason. I'm not 100%, but this is the only reason that I can really find for this existing. If you try and create a new database master key and you provide the same password, you get this error message that says that the adding an encryption key has failed because the encryption is already using the same password. I think the thumbprint is essentially being used as a checksum to make sure that these, you're not repeatedly adding in the same database master key. I don't know why that's so important, but Microsoft obviously felt that it was enough to be able to build this functionality in. So at this point, I'm getting a little bit excited, right? So we've got a new hypothesis now. We're going to look really smart. We're going to be able to go back and say, actually, this key material is actually held within the database itself, and it's decoupled from the service master key in some way, because DPAPI isn't a factor here, right? We're just dealing with the password. But we need to understand a little bit more as to what algorithm is actually being used to be able to hash this password, just to kind of understand whether we can go forward and kind of brute force it or chuck it into Hashcat or wherever it needs to be. So in terms of the algorithm that's being used, this depends a little bit. Well, it depends primarily on the version of SQL Server that has been used to create the database master key. So in the lab environment that we set up, we had two versions. We had SQL Server 2008 and 2012. I think it might have been a later version than that. So with breakpoints added into the bcrypt hash data function, what we actually find out is that ESP2, which is the type field that we saw earlier on, which Microsoft didn't kind of dig into the details of what that actually meant. That actually comprises of SHA-512 thumbprint. That's salted with 8 bytes, and the result is then truncated to 24 bytes. So that's primarily, if you see ESP2 within the type field, that's primarily what's happening here. So to be able to kind of brute force this, what we need to do is to use something like John the Ripper or Hashcat. I chose John the Ripper here just because it was quite easy to add in like dynamic hash formats where you can do the truncation, which was causing a little bit of a stumbling block. To be able to create a hash format that looks like this, which is the salt, and then the hash as well. So I've got a little bit of a demo just to kind of show this end to end. I will kind of pause and show you guys the important bits because I think that might be a little bit too small. So basically what we're showing here is that we're going to clear out the database master key, and then we're just going to recreate it. Now we can see here the thumbprint value that's been added in as well. And we've got a word list of six words just ready to go. And my Vim skills unfortunately aren't brilliant at this stage, so you can kind of see me chopping through a little bit to try and reformat the hash. And then we're just going to force this through John the Ripper with the dynamic rule that we've created. And we see there that we've got a crack as well. So quite good for us. It means that we've now got a way to be able to take the crypto key that's being used to generate the database master key, and then offline from a backup file, we're able to kind of brute force that. Okay, so ESP2, so that's kind of out of the way. What about ESKP? Now, Microsoft, I think, sometimes just like kind of sweep certain things under the rug and assume that nobody's going to notice. And obviously we like to dig into things a little bit more than what kind of a sane person would do. So ESKP is actually MD5 and it's salted with 4 bytes. So obviously for anybody that's done any brute forcing in the past, this is going to be rapid for us to be able to kind of sift through. So the hash format will look like this, and it's supported with Hashcat like out of the box, right? So nothing too complicated here, just a case of us knowing exactly what this will be. So again, another very quick demo for you, just to kind of show this in play. But we can actually use Hashcat for this rather than John the Ripper, so we get the full speed of Hashcat to be able to do it. So I'll skip forward a little bit. See here that we got the thumbprint value. And you'll actually see that my Vim skills improved between these two videos. Like I'm rapid now. And then we go through and yeah, password's cracked using MD5 with salt as well. So kind of useful to know as well. So obviously the next point is, well, nobody uses SQL Server 2008 anymore, so that's kind of pointless. It's going to be SHA-512. Well, of course they do. A big part of what we do here is kind of living the legacy of these systems. So you'll quite often find that you'll see, SQL Server 2008 systems as much as you'll see, Windows Server 2003 systems still kicking around. So you do still see these. Actually, the interesting part here is that if you've got a database that's been encrypted using SQL Server 2008, and then it's slowly been upgraded to use later versions of SQL Server, the original ESKP key value still stays within the database itself. So if you've got a database backup, and you kind of pull that, and it's actually been a later version, you'll still probably find ESKP values within there. There's also another interesting concept as well. So, if there's any database admins in the room, you'll know a lot more about this than I will. There's a few different ways to be able to do things like rotate encryption keys. You can do something like this, which is to alter the master key and add encryption and then provide a new password. What I found interesting was, even though that seems as though you're about to re-encrypt the data, all it actually does is just appends another row here. And it encrypts the same database master key with a new password. So now you're like twice the trouble, right? So there's now two passwords that can be cracked, and either one of those can provide you with the underlying database master key, and it's all the same. Actually, what you need to do in this situation is to rotate the key itself, which is another kind of field within the alter master key T-SQL. I can't remember what it is off the top of my head, but there's another way that you actually rotate the encryption here. But I thought that was quite interesting, because I'm going to guess that multiple people have made this mistake. You add a new password, you assume that you've changed it, and actually you've not. You've just made the situation somewhat worse. And also, if you go through and add an encryption key as well to try and get out of this situation where you've got like the MD5 thumbprint, even though it will add in a new entry, which will be for SQL Server 2012, like SHA-512, you'll actually still be left with the MD5 password within the database as well. So you'd have to go through and clear that out, essentially. Okay, great. So we don't need the service master key. We've got the database master key. And as I say, if you kind of break this layer or any one of these layers, everything below that kind of falls. So we're in a very good situation here to be able to kind of pull off this attack that we're being asked to do. So that's the detour over. So we need to go back to the original request itself. I made that look really simple, but that took quite a few nights of banging my head against the keyboard to try and figure out what was going on. So now we know how Microsoft SQL Server Crypto works. We need to kind of brute force what we've been given by the team to try and access some of these sensitive key materials. We really hope that when we look at the type against the thumbprint, that it's going to be ESKP format. And it is, which is great. It means we can use MD5. And the key itself hadn't been rotated in a long time. So, kind of when you've done like Kerberos and stuff like that, you'll primarily look for passwords which haven't been set in years. Normally kind of gives you the best shot at recovering a password. And it basically failed to crack. So, I mean, again, you've done all this work and you've kind of gone along and you're really happy with where you've got to. And then actually at the final moment, you still can't crack the password, which sucks. Experience tells us that something's just wrong here, right? So everything should have led to this password being revealed. So again, we're going to have to do a little bit more work. We're going to have to go through ManageEngine to figure out what's going on. Now, the ADSelfService product and a bunch of other products by ManageEngine are written in Java. So you can fire up things like JD GUI and kind of reverse engineer this. So it comes apart very nicely. Actually, what I found, like probably way later than I should have, was that there was a file called productconfig.xml, and it had this key in there. It looks random, not ideal again. In the lab environment, I could prove that was the key that was being used. And then we take the key, and I thought, just on the off chance, I'll throw this into kind of the database that we're looking at cracking, and it cracks. So it's like, well, what the hell? Like, why is this thing like the same? So I just believed it like it was a hard-coded key that ManageEngine had left in the product, which is bad enough. Actually, when you Google what that key is, so that key is actually the sample key that Microsoft provided in their documentation for setting up database encryption. So what that basically means is that this product, and I checked this last night to see whether it actually changed anything, and they've not. So that product with database backups is using a encryption key, which is the sample encryption key that Microsoft provide in the developer documentation. So that's basically where it comes from and why it looks so random. But so as I say, in this case, we've got the password, which is the database master key. That can be used to be able to unseal the Zoho certificate, and the Zoho certificate can be used to unseal the Zoho symmetric key, and that protects the data. And basically, you can kind of reveal the data that's within there. So obviously, within ManageEngine, there's going to be sensitive data stored in there. So we can see here quite clearly in the documentation, domain admin credentials are going to be stored within this database. And that's exactly the case here, right? So we've got the decryption key that we use, and then we can start to kind of go through the data and kind of select the field out, and we get the clear text domain admin password from the database backup as well. So takeaways from this are that the ManageEngine self-service hard-coded password is the sample documentation password. So as I say, do with that what you want. It's there in backups. I don't know how long it's been there for, but it's still there until this day. If you find a database backup which is used for this product, that's the key essentially. So you can use that to kind of like reverse the encryption and access the data from there. If I would have known that up front and I just would have taken a look at the XML, I would have just been able to Google this and figure it out in a couple of minutes instead of like multiple nights of reverse engineering SQL Server to find out what I just needed to Google. But, that's the case. You don't know what to Google for sometimes. So sometimes it's a little bit difficult. So in terms of fixes, it's the obvious stuff really. So, password hygiene matters with this kind of stuff. I think some of the difficulties sometimes are knowing how to explain this to database admins and application developers if they don't necessarily know how, kind of at risk some of this data is depending on what that password is. So now we've got a method to be able to kind of brute force that. So if you see any .back files kind of on your red teams, you've kind of now got the ability to go through and have a go at brute forcing some of these values and actually access some of this data. In terms of ADSelfService, this issue exists, unfortunately, and it's there within the backup files. You will protect backup files as you want to, but quite often you'll find backup files on open shares. So unfortunately, this situation is going to be around for a little bit of time. If you are running ADSelfService or any one of those products, obviously I've not taken a look at the others, you'll need to rotate those encryption keys and just update the product config.xml file as well to make sure that kind of everything still continues to work. And that is everything. Thank you very much.